Hi, Liz. Good morning for all. And today the discussion is Wipro, the first round of interview questions. And this interview was done and 18/12/2025. Okay. In this interview, it is a DevOps engineer profile. So they will ask to how to create. Can you please write a pipelines and Jenkins pipeline and some other questions that they are asked, and we will discuss one by one. Okay, and let me start with the first question. Okay, so can you please write an Azure pipeline? So they're asked to can you please write it. So in this scenario, the application architecture pipeline or the infrastructure pipeline, there are two pipelines. So let me talk about the application architecture pipeline. Here, so we are source code, we are in Git repository, or we will take it like Azure repos. We clone by using our Azure repos. The source code in a Git repository, we need to take it by using of Azure repos, and the languages we are working with the Java based application on Node.js. Or so Java we can go with the Maven, or Node.js we can go with the NPM. So the build tools are Maven or NPM, and containerization we are using Docker, and registry are it is comes under Azure cloud, right? So we will take it at registry like Azure container registry. The runtime, so we are deploying it to that EKS cluster environment. The pipelines, the multi-stage pipeline and YAML. Okay. So how the what are the stages here? So one is thing code commit. So whenever a developer push to the code to the main or development branch, the Azure DevOps pipeline get triggered automatically. So we have to given this trigger on that main. So ensure the continuous integration process. Okay, and comes next stage is the build stage. So in this build stage, so we compile the code and generate the artifacts. The steps are we included the install the dependencies and run build commands and generate that artifacts. If we are working here, we are working in the Java based application. That's why we are using to Maven take as a build tool, and in this below inputs we have to Maven clean packages. Okay, here we can remove the old artifacts. Okay, Maven clean install, so old artifacts should be clean and generate the new artifact. Then the third stage is code quality and security. After build, we perform the static code analysis. So we are using static code analysis by using of SonarQube to check the code quality and the dependency with the scanning. That's why we are going to static code analysis because it avoid the duplicate deploying the bad or vulnerability code and enforce the quality gates, maintain the quality gate and or duplicate the gore and vulnerability. We need to identify and before deployment. Then the fourth stage is the Docker image build and push. Here, once the code is passed quality the checks, and we have to build with the Docker images. So build a Docker image and tag the build ID and push to the ACR, ECR or registry. So the Docker build command, this command, so Docker build hyphen T, and our repo registry name, then the build ID. So for this command to push to the our remote registry like that ACR. Okay, so why we are pushing? So image is versioning is very important. That is why we have to, for the rollback purpose, we have to provide that we have to provide our image from local image to remote registry. So after image post completion, it is the fifth stage. After image post completed, deploy start automatically. The Kubernetes manifesto for and the Helm, so we have separate environment and dev, QA, and prod. So in this separate environment, we have to be used for this command kubectl apply and find deployment.yaml. Um, now, yeah, here we pull the images automatically, and then deployed new for the new they pull the new image and deploy automatically. Then, so environment approval. For production, we need a manual approval. So that is why we have to be some process management, prevent the accidental production deployment, the follow the change management process. In production, so we have to create the CR and then we have to get the approval, then only to do the deployment process. Okay. The post deployment, after deployment is successfully completed, we have to check with health checks and pod status validation and smoke testing. If deployment is failed, automatically roll back by using a previous image, which is already be pushed into the our ACR. Okay, and then so this is the rollback story. So if your production failed, we redeploy the previous stable of Docker image from ACR. Example, kubectl rollout undo deployment that deployment name. Okay. For security conditional management, so we are manage the securities and key vault integrations, and then Azure DevOps variables groups. So example, database password, API keys, and service principal secrets. So here I will give why AML is preferred. So it is a version control and easy to roll back the same pipeline across multiple environment, like day one stage and product. So infrastructure as a code is mindset. Okay. So interview side on online answer. I design and maintain a Azure DevOps multi-stage pipeline. And the pipeline that automate the build and test Docker image creation, ACR push and AKS deployment with approval gates and rollback is support. So in this type of questions, not only Wipro and the recently, I mean, 3 months back I faced one startup company. That company name is National Benefits. So they want to own Azure DevOps profile candidates, and that company I attend, and I was attend that company, and they asked to, are you experienced with Azure DevOps pipeline? Are you created with multi-stage build? This type of question they are asked. Okay. And I will take one example. So this is my Git repo. Let me open this repo. Okay. So first we have which is item Azure subscription, Azure container registry, and service principles. Azure DevOps organization project, and agent will be Docker install and Docker file, and the repo was linked with Azure DevOps. Okay, here I need to create it with the first the step-by-step process. One is a resource group. So resource group is maintain the group of resources in Azure, in Azure, one of the centralized services and a resource group, and under same resource group, we have to create it with the VNet, subnets, and public internet gateway. So here is command we have to create the virtual machine. There we have to give in the some public IP to log in those tested server. Okay, then this is a which I created VM. It is a self-hosted agent too. We have to we need to register with Azure agent, Azure DevOps and agent pool. So in Azure DevOps in project settings, there is a agent pool. You need to add pool which is already created at the VM. Okay, then okay, why we need to go with create with a self-hosted agent? Because if we manage we huge jobs we can run, and we can manage the infra our own only. That is a case we can go ahead with the self-hosted agent. So there are two agent, Microsoft agent and self-hosted agent. So Microsoft agent, there is a limited access and limited hours working. So that is and we are not we cannot run huge jobs also, because that is that is the case, and instead of using of Microsoft Agent, we are using self-hosted agent because everything in our hand only. We can managing infra everything. Uh, Okay, for the few steps we have to create install step the agent installations, and then there is a part in Azure DevOps organization. We personal access token we have to be provide. Then only to be our agent to authenticate with the Azure DevOps project. This is a command to the run. Okay, and then we have to be created with Docker Hub service connection because in the project settings we have service connection. In the service connections, we in Docker Hub username and Docker Hub password we have to be provide. Then only to authenticate. We can push the image to the in our project to the from your project to our ACR or Docker Hub. So this is a command this is a command to create the ACR service connection. And okay, this is a simple Azure pipeline. Push, build and push the image to the Docker registry. So trigger the path. We, this is a path. For example, we will take it as a result. In this result folder, we have all these files. Project related files are there, and then in this variable we have to provide with Docker Hub connections to authenticate. Then in pool we have to give an self-hosted agent pool name. Then under stages, the job display the name, build and push to the Docker Hub. Under jobs, we have job name, Docker build and push, and under jobs we have steps. In the steps, so we have to give in the commands, build and push. So this is a container service connection. Okay, similarly we can go ahead with the Azure pipeline with ACR. Okay. Similarly, we are created here also same. Okay, and let me go with some other uh, questions. Okay, can you please write with pipeline? Okay, here I have implemented with declarative pipeline and to automate the build, test, and Docker image creation, registry push, and Kubernetes deployment with manual upload rollback support. Here, let me go with, we have multiple stages. Similarly, one is pipeline trigger. So whenever developer is commit that code and to Git repository, Jenkins pipeline to trigger with automatically using of webhooks. And why we enable the continuous integration, no manual build triggers. Okay, that is a case we are using GitHub push. Git web integration. One is checkout. We have to be clone that Jenkins pull the latest code from repository. So that is checkout stage. So this is a command our get repo. Okay, then build stage. In this build stage, we compile the application and generate the build artifacts. Mav and clean packages, or if you go with a Node.js, npm installation, npm run build. This is a command to build stage, and then after build, we run the unit test and static code analysis by using of JUnit of SonarQube. Why? So catch the bugs early and maintain the code quality standards. And under that, there is a command to testing stage, and then Docker image build. In here we are provided the Docker build command. Okay, under stages steps we have to provide this command. So the tag of image is the build number for our version. The push to the image to registry. Okay. Here the credentials we have to be provided into that manage credentials into that Jenkins dashboard. Then only to you can push our image to our the credentials are securely stored into that Jenkins credential manager. After that, deploy the our stages. After image is pushed, Jenkins deploy to the application to the Kubernetes. Uh, okay, this is a command we have to deploy. So, and dev and QA and the prod is manual approval. Okay. Um, the production deploy we need to manual approval. Why? Because avoid the accidental production issues and follow the ITL change management. Okay. Then the post deployment we have to check the pod station validation services URL and monitor the logs. And the rollback, we can go ahead with the kubectl rollout undo the deployment. The image version, image R version, and previous image was available into the registry. So credential management, Jenkins credential or environmental variables as Kubernetes secrets we can manage. Docker registry password, DB credentials, and cloud access keys. Okay, the one line answer I have to implement it with Jenkins declarative pipeline and to automate the build and test Docker image creation, registry, and push. Kubernetes deployment as manual approval and rollback support. Okay, here I will take one my repo which I created recently. Okay, as in the Jenkins pipeline. So Docker build and run and push by using of Jenkins pipelines and Docker Hub with Git repository. Okay, I have done this testing pipeline and 14/6/2025. So here I have to set up with Ubuntu server and Jenkins installation. These are command I have to install with Jenkins as well. And then we have to go with the Docker installation into that master server, and we have to give in this permission as well. Then we need to we can create the images, Docker images, and then after that, after giving that user mode permissions, then you need to restart the Jenkins. Then you go with manage plugins and Docker Hub and Docker Hub registry and to provide with the Docker Hub credentials. Okay, means user ID passwords. And then so create a repository in GitHub and you need to provide the Docker file into the Git repository and create a Docker Hub repository. So under pipeline agent any and then environment, image name, image tag, and container name. So here image name we have to our Docker Hub repo and image tag is this one and container name is. So checkout we have to be checkout and we need to clone from remote git remote repo to in Jenkins. This is a command to Docker build and push to the Docker Hub. So here is the Docker Hub creds, which is already created into that Jenkins managed credentials. This is a ID. In this under this ID, we have to provide with the user ID passwords, Docker user ID passwords. So that's why we have to provide with ID here. Then only our pipeline will work, and then only you can create the images, and you can push to that image to that you know um, Docker Hub and Docker run container. If you have any old container, this command we need to remove, and then you need to run this command to run our container and run. This is internal port and an external port ID. So this is for external port and this is an internal listening port. Image name is image tag. It will take from the environmental variable, okay, which I given here, environmental values. Okay, then it should be working fine. Similarly, we can go with ECR. So here I'm working as a Docker Hub, and here I'm working ECR, Elastic Container Registry. Okay, the same for now, and this is only something we have to change it. The AC, AWS region, ECR registry, and ECR account ID, AWS creds have to be created Then we have to provide it the access key and secret keys. Then yeah. Okay, let me go with here. So then they are asked to, can you please explain the Kubernetes architecture? So they are asked to me and go with the paint and then can you please explain with the diagram. So I that's why I have to take in this diagram. In this diagram, with under master node, I know API server, etcd, kube control manager, scheduler, cloud control manager. In worker node, kube proxy, kubelet, and container runtime. Okay, and let me go with one to one. So in my project, we deployed a containerized microservice using of Kubernetes to archive. One is high availability, auto scaling, and the high availability means multi agents, and auto scaling means we can scale our whenever loading happen, and whenever high load is happen to in cluster levels, the scale our it is a cluster auto scaler and an horizontal pod auto scaler self-healing process, and it is automatically self-healing means if anything happen into the container level or pod level, it's auto healing themselves and restart themselves only. So that's why the zero downtime deployment, there is no downtime, we can upgrade our deployment activities. So our Kubernetes cluster, we are running cloud managed services and Azure AKS and AWS EKS. Let me talk about with two major parts. One is under master node is we have control plane. In control, the master node is a control plane. So brain of the cluster and decide to what should happen. Worker node is does actually work and run the application into the worker nodes. Okay. Um, for example, if your master node is down, okay, our application will down or not into the worker node. Someone asked to me, and here, if master node is down, so application running into that worker node side, right? So if master node down, but application worker nodes are working fine, the application there's no impact, so they will work. But here no schedules are no schedules not working into that any worker nodes, but already existing applications are working fine if master is down. Okay, let me go with the control plane, and API server is a kube API. API server is the entry point of the Kubernetes, and the developer run in the kubectl apply command and request you go to the API server. The API server is validate the AML and authentication. So it's all communication happen only for API server only. So next is etcd. So it is a cluster database. etcd is a key value database of the Kubernetes, and it stores the cluster state. All cluster information is stored into the etcd only, and store the pod definition and secrets and config map. If etc down, cluster is broken, and we have to maintain that desired replica equal 3, and etc store that state. So for example, if you run it 100 replicas, those information stored into the etcd, the information will communicate to the API, and API communicate with scheduler. Scheduler run to the communicate with again at the API, and API server is communicated with the worker nodes. In this worker nodes, kubelet will maintain the jobs to the worker nodes, and kube proxy to allow the traffic into the worker node side, and container runtime to maintain that maintain, and they pull the registry from image and maintain and running properly. And a scheduler, it is a scheduler decided to where should run. API receive the pod request at API, and the scheduler check the CPU memory and node availability. Pick the best work node, and this node 500 MB, so node 2 is the best. Okay. And control manager. Controller is ensure desired state, actual state. Desired is replica equal 3. So one pod is crashes, the controller notice is mismatch and it create a new pod and automatically. So in this controller, so we maintain with the replica set controller, node controller, deployment controller. So if something gonna happen in any of the pod, and it automatically notice the mismatch and create a new pod automatically. Maintain our replicas, node replicas or deployment set replicas. Okay, it is keep the self-healing process. Let me go with worker node side. And worker nodes is kubelet is a agent is running in every node. Receive the instruction from API server and take to the Docker and container runtime. And ensure the pod is running. The start this pod and pull the image and run the container. Here, container runtime. So, responsible for running the container. Is container runtime responsible for running the container? Examples of container D and CRIO and Docker. The kubelet set is run Nginx image and runtime is pull. It is runtime. Is container runtime. It is pull the image and start the container. Okay, it is responsible for running of the container. A runtime is pull the image from start the container. Okay, let me go with proxy. The proxy is handled to the networking and load balancing, and user hits the service IP. And each pod has there are specific IPs. Their internal IPs delegated and user hit to the service IP and queue proxy route the traffic to the correct pod and use the IP table and IPv6. Three pods are, for example, we can three pods behind of one services. These services static service and queue proxy is balanced traffic. Okay, and what is a pod? Okay, and I attend one of interview like EY. They are asked into what is the difference between container and pod. So pod is one or more container and share the networking storage. Container is a it is a processor. And we deploy the application as a container. Sorry, we deploy the application as a pod. So inside of pod we can run multiple container. Okay, that is only we need to remember it. So one pod can have app container, sidecar container. Okay, and kubelet networking storage. So each pod get unique IP. Unique IP. So pod communicate with via IP only. Service provided with stable IP. Ingress exposed to app to outside world. So Kubernetes networking, it is as like we can take it up Calico network policy, and so so then networking are this network are used for each pod as specific private IP, and there are multiple IPs to connect with single service that is called stable IP. Okay? And here is the flow request and user hit to the application URL. The traffic enter via load balancer or ingress and service route the traffic and queue proxy forward to the pod and pod container server request and the response go back to that user. Okay. And the self-healing process, the pod crashed due to the memory issue. So kubelet is detect the pod failure and control manager detect the desired replicas. And no new pod was created automatically and schedule assigned to the node and application become available again. So this is for self-healing process. And the secret config management, secrets passwords we can manage the secrets and config map environmental configuration we can manage and RBACs for role-based access control. So some new user able to access with our cluster level access, we can go with RBAC. Okay, namespace it is isolate the cluster level. For example, dev namespaces and production pre-prod we can isolate it by using of namespace only. So Kubernetes architecture consists of a control plane and manage the cluster state and worker node to run the worker node and enable the auto scaling and self-healing high availability containerization operation. This is the concept, Kubernetes architecture. Okay. Control plane, we have API servers. It is a centralized communication, the front end of the layer. Okay, here that every cluster need to be application run to the pod, and API server is that control plane expose the Kubernetes, and API server is the in front end of the Kubernetes control plane. Okay, and control manager, controller manager to maintain the replicas, node controller, and then scheduler and to the maintain job schedule to the worker nodes needs to show the information, and cloud control management manage the load balances later. Kubernetes, proxy, and container CRI. Okay. Then keywords. The keywords. Then second question they are asked, how do you experience the worlds? So Azure keywords. Yeah, I have experience with Azure keywords. So secure the services, store the manager secrets and encryption keys and certificates are commonly used for protecting sensitive data integrations applications. Okay, and they then ask for Python experience. I have experience. I said. Then they will ask how to troubleshoot the issues into the image pull back. Kubernetes questions. Okay, image crash to backup, pod pending stage, image pull backup, and error image backup. Okay. So let me go at a little bit about each and every issue. Image pull backup, it is the image issue. Wrong image and private registry. An image name and tag verify, image pull the secrets we need to add, and register access we need to check again. And then error image. Error image does not exist. And the typo image name and registry is down. So correct the image and registry connectivity check. So there is a little bit difference with error image pull and then image pull backoff. So image pull backup is happened Kubernetes failed due to pull the container image. And here error image, the error is not, the image does not exist. First image pull failure because backup error. So image does not exist into the registry. And pod pending, so it is an insufficient CPU memory or node selector or PVC not bound, and taint and toleration is okay. We need to cluster order scaler, we maintain it and reduce the resource quota and PVC tolerations we need to check. Scheduler could not be find the suitable node. That is the case. We get error pod pending crash loop backup. So it is application wrong crash or wrong command, and config environmental variable, check the logs, fix the command, and correct the probe as well. So crash is occur when container is repeatedly crash after starting. So we need to be checked for above scenarios. Home kill is out of memory issue and weak memory kill and kernel. So low memory limit or application memory leak. Increase the memory limit into the resource quota level, then only we fix it, or we are enable the auto scaling. Okay. So home killed means out of memory issue. It can happen when container exceed the memory limit. What is the config map? They are asking again. So config map, how to check the config and what is the command they are asked. Kubectl get config. This is a command we can under namespace we can go ahead with the namespace command also. I use kubectl get config man list the config map related information. Okay, and describe we can key values clearly. We can able to see on. Okay, and then. Um, I mean, how do you attach with the config map? So there are volumes and environmental variables. So the both way we can give the reference, and then attach with our pod. Check the ENB into the pod level as well. And we can check with after logging this command to log into the pod. We can check with under in env we can grab that value as well. So what are the commands they are asked? And for these commands, I explain. So kubectl get nodes and describe the nodes and top nodes, and the pod command get pods and get pods in the specific namespace, describe the pod in the specific namespace, get the logs and the I know how to log into that pod and how to delete the pod. And in a deployment, a replica set, how to describe the deployments and how to scale it to our deployment, how to roll out strategies, how to roll back command, roll out onto deployment our name, and the services we have to check get SVC, describe SVC, and port forwarding. This command we have to check the services and sorry secrets and complement command, get the secrets. So secrets and config map we can go with under env we can go, we can give the reference and that can then we can attach with our pod as well. Namespace get ns and create the ns and delete the ns. Namespace is isolate the network only and cluster level. Mm, this is a command too we can apply and delete the node maintenance, the cordon and drain. Cordon we can unschedule and drain. We can, evicted our pods. Okay, uncordon we can unscheduling. Drain means already existing pods should be, removed. Our worker node. Monitoring command and events. This is a command we have to check it for debugging. Okay, that's it. And how to monitor CPU and how to exit, how to troubleshoot. For example, I'll take it one example. The CPU is 97%, and the which processing area we have to be check it. This user is Gary. So math processing. So I need to monitor with CPU by using Linux command, kubectl pods and cloud monitoring dashboard. When CPU has exceeded threshold, identify top consuming process and check the load average and application logs. Then resolve its scaling or optimize and upgrade the resources. Or which is a process whose process is running right, the CPU utilization running more. Then we have to be kill it as well. We'll get the approval from our application team. Then we have to kill it and restart the if it is services. Then they are asked to application gateway. How to experience with in Azure? So application gateway, it is a OS layer L7. Provide the feature is like SSL, LLS termination, auto scaling, and zone redundancy and integration with web application firewall to security. One more they are asked what is SSL termination? Okay. It is termination means the client side we are using HTTPS and between that client to load balancer, load balance to server we can go ahead HTTP. So we can reduce our CPU load. That is the case we can go ahead with SSL termination. Um. Okay. They are all comes under Wipro first round interview. And before I shared one interview, that is L&T Mindtree, and this one is Wipro. Um, these two companies I faced in back to back, but they don't give any feedback. Unfortunately, I'm not upcoming interview. I'm unable to share with the second round of interview because they don't give feedback for these two companies like L&T Mindtree and Wipro. And okay, yeah. I hope this in video help to you also. And thank you for watching for this video. And we'll share the upcoming videos and upcoming interviews and SRE and cloud infra. And okay, yeah. Thank you. Bye bye.